Okay, so we've got this surface here. So we can tell that it's a surface because we've got x, y, and z, and we've got an equation linking those three things together. So if we've got 3 dimensions and 1 constraint, we end up with a 2-dimensional object, and that's a surface. We're told that A and B are positive. You can assume they're constants, but you don't know what they are, and you don't know their relationship. So you just have to kind of live with that, and there are some consequences, as we'll see. We're going to sketch this thing. So we're going to work out, firstly, what some contours might look like. Contours are the sections where z is some constant. Z equals const. So let's pick the easiest one, z equals 0. We've got ax squared plus by squared equals 1. Now you should know that this is an ellipse. So if a equals b equals 1, we'd have a circle of radius 1, right? Because we've got an a and a b, and we're assuming they're different, we've got some ellipse with some major and minor axis. Because we don't know the relationship or the relative sizes of a and b, we don't know which direction our ellipse is stretched in. So we'll just make an assumption for sketching purposes. But essentially this just comes down to an axis scaling type thing. Right, so there's our ellipse. If we've got y equals 0, we know that x is 1 on square root a minus 1 on square root a. This will be 1 on square root b minus 1 on square root b. Right, that's the z equals 0 contour. Let's do the z equals 1 contour. That's obviously ax squared plus by squared equals 1 squared is 1. Take it over there. That equals 2. We've just got a bigger ellipse. Right. This is now 2 on like that, and that's 2 on b, right? And the minus ones as well. Z equals minus 1. Because we've got a squared there, we're just going to get exactly the same thing. Right? Squaring minus 1, it's just 1, so we take it over, we get a 2. So this red line actually represents the z equals plus or minus 1 contour, and the purple line is z equals 0. All right, so that kind of tells us that this thing is symmetric in z, right? So z equals 0 is a plane of symmetry. Let's work out what some of these sections might be. So let's work out the x equals 0 section. That's going to appear in the YZ plane because they're non-zero. We have by squared minus z squared equals 1. That's what we get when we plug into our equation. So we have z equals by squared minus 1. So we get plus or minus y squared minus 1. So if y is no, I want I've made a sign error here. Just doing that too fast. Oh no, I didn't make a sign error. Oh, it did. Right. So obviously this is going to be undefined if y is less than 1. So the only time that this is going to give us a real result is when y is greater than 1. So if, or actually, sorry, it's greater than 1b square root, right? Because that's what's going to give us something positive in here. Other than that, we're going to get something that grows like the square root function. It's going to be a bit faster than that because we've got a squared, but we still got this -1 thing. We're going to get something that looks like that for the positive branch, and we're going to get this for the negative branch. Obviously, because we've got the squared here, right, everything that I just said for this side of the domain, the y positive side, also works for y negative. So we've got this kind of behavior, right? So a hyperbola in the YZ plane. If you look in the XZ plane, instead, you're going to get Z equals plus or minus a x squared minus 1. So you're just going to get different hyperbole. Okay, so now you can kind of put these bits together. And remember, obviously, that you've got this sort of symmetry going on. You can see this symmetry reflected here, right? You know that your Z equals 0, everything's just reflected around Z equals 0. So let's try and sketch this. Out. In the XZ plane, we've got a hyperbola like this. I'll draw that in yellow. We know that this point's going to be this is minus. I'll draw this one in black. That's 1 on root B, and the corresponding -1 as well. Whoops, that's pretty bad. Right, so we've got this, and now we can start drawing in the contours. We've got an ellipse that goes through these points here. Then we've got an ellipse that kind of connects them up at the top. And we've got the same ellipse kind of hits everything at the bottom. I'm just going to try and fix this line because it's a bit, that black line there is really scummy. Oops. All right, and that's the sort of best that I can draw this thing on some axes. If I tried to draw it off the axes, I'd probably do a bit of a better job, because you can kind of see now what it looks like. Kind of looks like this. It has this shape with a round shape with a kind of waist around the middle, like that.